In the following example, we're going to estimate the distance between the centers of any two adjacent atoms within a solid macroscopic object. So let's begin. The density of solid lead is 11.3 times 10 to the 3 kilograms per meter cubed, and the mass of a single lead atom is given to be 207 unified atomic mass units. Approximate the mean or average distance between the centers of two adjacent lead atoms. So before we begin, we have to define the shape and size of our solid lead object. So the shape and size could be anything. So let's suppose we want to consider a cube of lead atoms in which each side of the cube, each edge, has a length of 1 meter. So 1 meter height, 1 meter width, and 1 meter length. So the number of atoms along any edge is given by n. We're going to need to calculate this number n to find the distance between the centers of any two adjacent lead atoms. So we break down our problem into 4 steps. In step 1, we want to determine the mass of this entire cube. To calculate the mass of this entire cube, we simply use the density and the volume. Recall that density is equal to mass divided by volume. So if we take that equation and rearrange it, we can solve for m, our mass. So mass is equal to the product of the volume and the density. So the volume is simply 1 meter times 1 meter times 1 meter. So that's 1 meter cubed. And the density is given to be 11.3 times 10 to the 3 kilograms per meter cubed. We multiply these values out. The meters cubed appear on top and bottom, so they cancel out, and we're left with a mass of 11,300 kilograms. Now, in step 2, we want to determine the number of lead atoms inside this entire cube. So to calculate the number of atoms inside the cube, we take the total mass of the cube and divide by the mass of a single lead atom. So the mass of a single lead atom is 207 unified atomic mass units. So we take 207 and multiply by 1.6605 times 10 to the 27, negative 27 kilograms to convert from unified atomic mass units into kilograms. So we have 11,300 kilograms, the total mass, divided by the mass of a single lead atom in kilograms, and we get approximately 3.29 times 10 to the 28 atoms, lead atoms, found in this volume of lead. Now, in step 3, we want to use this value to determine the n number. So the n is simply the number of atoms along any given edge. So recall that volume is equal to the edge L cubed. So if we rearrange this equation, we see that L is equal to the cube root of the volume. So we know that we have this many atoms in 1 meter cube volume of lead. So that means we take this value and we take the cube root of this value. And we find that each edge has a number of 3.2 times 10 to the 9 atoms. So each one of these edges has this many lead atoms. Finally, in step 4, we calculate what the distance between any two adjacent atoms is. So notice that the length of each edge, as shown, is 1 meter. So to calculate this distance between the centers of any two adjacent atoms, we simply take 1 meter and divide it by the number of atoms along that single edge. So 1 meter divided by 3.2 times 10 to the 9 atoms gives us a value of 3.125 times 10 to the negative 10 meters per atom. So because every single atom is assumed to have the same exact diameter, and because there is no space, or we assume that there is no space between any two atoms, that means the length or the diameter of a single atom is equal to the distance between the centers of any two adjacent atoms. And the distance is given by this quantity. In fact, we can use any solid. For example, if this was copper instead of lead, we simply take the density of copper and we follow these same 4 steps to calculate the distance between the centers of any two adjacent copper atoms.